Hello. In preparation for July 4th, this is a little Marquee display program. So if you have an Apple, you could put the monitor in the window very carefully, and you can run this so the neighbors can be all impressed with your skills. So it's really a low-res graphic letters that are scrolling across, and there's a little machine language scroll routine that I'll walk you through in a later session. So what I want to do is transfer this 5 1/4 floppy disk to a disk image. So how do I do that? Well, I luckily have a PC transporter in my Apple IIe, so that is a card that allows you to run IBM software on an Apple II. So just to give you an idea, this is the catalog of the disk. So it's just a DOS 3.3 disk with several programs, different types of marquees. But now I'm going to boot my hard disk, the Vulkan hard disk, and I'm going to go into the PC transporter. So it's on my Prodos slot 5 drive 1, and I have a menu to run a 16 megabyte partition for PC transporter. Okay. Loading from disk. So it's first looking for a 3.5 inch floppy, and now it's going to the hard disk, starting MS-DOS. Okay. Now, I had a no-slot clock in here, but the battery ran out. So I don't think the battery on the original SMT no-slot clock is replaceable, so I'm going to have to look for an alternative. I see some of you people out there have built some hardware. It looks cool. All right, so now I am in MS-DOS on an Apple IIe. All right, so now I have a directory of my stuff here, and what I have is a program from Applied Engineering. So on the PC transporter, they give you a transfer program. And this is the coolest thing ever invented. Well, one of them. Okay, you can move from MS-DOS to Prodos or Prodos to MS-DOS. Okay, but before I do that, I need to get the data off of my disk. So I don't have anything to transfer yet. What I need to do is go back to Prodos, and I have to run another utility that I wrote to create a DSK file from my floppy disk. So let's go to Basic System, just exit to Basic, and prefix DSKXFER. Okay, so here I'm going to use a read track.base. So let me just run it. Okay, so it's a basic program that then loads in a machine language program to read each track. And so now it's reading track 0, and you're seeing the data coming on the high-res screen. It's saving it at byte 0 in the disk file. Track 1 gets saved at byte 4096, and so on. So we're just going to let this run. So this is Prodos, so it's making MLI calls. So we'll walk through this program in the future. But what's nice is it's reading the floppy disk and it's not getting any errors. It would break out with an error code if the floppy is bad. Okay, so there are 34 tracks on this. And the great thing about Prodos, you could save at any point in a file. So by saving at a specific byte, I could use the high-res screen as a buffer. Now you're seeing there's a lot of blank space on this disk. Feel free to use it for whatever you want. So you're getting 140K with a handful of programs and data. But you'll see on track 17 coming up, that is the catalog track. Okay. So I believe it's reading Prodos block numbers. So that's your catalog. And then there should be some data on these tracks immediately after, so you could get an idea of how DOS 3.3 stored data. It started at track 18 and 19 and 20. And then we'll see how much data I'm actually using on this floppy. Okay. This is mesmerizing. Okay. There are secret codes in these dots, by the way. Yeah. The aliens have sent us secret messages, or maybe it's from North Korea. Oh boy. Okay, so 26. And now, let's see, 27 is blank. So you got some blank space at the end of the disk. So that's what happens when you start a fresh 3.3 disk and start filling it up. And then I guess after 34, it will go back to track track 2, I believe. 0 and 1 are for DOS. Good old days when DOS fit in 2 tracks. You didn't have bloated operating systems. Okay, track 34 is it. And there's your 140K disk image. So just to take a look, let's look at it. Read track.object is the machine language, and I'll walk through the source code one day. And it's be saving the disk.dsk in line 200 at the byte that it calculated. Okay, so that read track utility, it has a poke. It's at 24576, which is hex 6000, and then you're poking a track number and a buffer 032, I guess. Okay, so yeah, from 3000 to 3FFF. So I could show you. Interesting. So I'm reading data. It's on the high-res screen. Interesting. I'll have to look at this. All right. So now, if I do a cat here, I now have a dsk.dsk, and then I just rename it dsk.dsk, marquee.dsk. Okay, so now I have a 283 block disk image, and you can see some other DSK files like America Online that I was doing. Okay, so now I need to transfer that to Prodos, and so what I'm going to do is buy and go back to Prodos and go to PC Transporter now. Okay, loading from disk, MS-DOS. Okay, we're going back in time to January 1st, 1980. All right. And now I'm going to CD APC transfer from Prodos to MS-DOS. All right, select Prodos files from a directory list, and I put in the path, hard disk exfer, and it shows me all the files on that directory in Prodos, and then I pick the one that I want to. You could pick multiple, and then return to start transfer. And now I don't want it in the AEPC. I don't want it in my AEPC directory on MS-DOS. I want it in \DSK xfer and marquee.dsk. So you want to use a file name less than 8 characters, 8 or less in MS-DOS. And this, if you have a text file that has carriage, the Apple carriage return only, it'll translate it to carriage return line feed if you say yes, and the other direction as well. I'm going to say no because it's binary. Spacebar to transfer, and the magic of applied engineering, it is copying from a Prodos partition of my hard disk to an MS-DOS partition of my hard disk. So it takes a little bit. It's 140K. It's thinking about it. Yeah, it's running. I hear the hard drive. The Vulkan, another applied engineering product. Okay. Return to main menu and exit from program. All right. So now CD DSK xfer, and I have my disk image. Now what I have to do is copy it to a floppy. Oh my, a 3.5-inch floppy. All right, let's take a look. So I'm using my Apple 3.5 drive. Now on a PC transporter, the rule is the 3.5-inch drives are connected after your trans drives. So I have a 5.25 trans drive that I'll need someone to help me repair someday. But the 3.5-inch Apple 3.5-inch drive works as a trans drive. So I could go to A: now and do a directory and see what I got here. And I'm going to copy C: Marquee DSK. And the magic of that is once it's on a 3.5-inch floppy, all you need is one of these things, a portable USB floppy, and you could copy it to a PC and then upload it to a website or whatever. And then you could run it in an emulator. So like to get it on a Mac, I would just upload it somewhere and download it onto a Mac and save it and use it in the Virtual 2. Okay, so now I have it. Okay, so that's PC Transporter. Let's go through this. I wonder if I could hook up this floppy to a Mac. Let's try it. Okay. Now, let's exit PC Transporter. All right, I'm going to turn off the Apple. And I'm going to turn on the Mac. Okay, so the great thing about this is you can take that floppy disk, the USB floppy, and plug it into a Mac. I just plugged it into a Mac Mini and then open the floppy in Finder. And then you could copy your disk image and then you could actually run it in Virtual 2. So let's go full screen on Virtual 2. And here you have your catalog. Oh, we're in DOS 3.3. So, oh, the great sound of a disk drive. Okay, so let's take a look at this. So the Hello program, it's just running Holiday 2001. So you could change it to run any of the others, like Halloween or Hanukkah. Okay, so but let's load the Holiday 2001. Oh, there's a little dot in the corner there. Okay, and let's run it. Okay, so it loaded the Shift Text program, and it's doing the Marquee. So you could actually take the monitor from a Mac and put it in your window for 4th of July. Okay. So just to take a quick look at the program. All right, so I'm just going to let it scroll through, but basically you're just plotting on the rightmost column and then shifting everything to the left by calling a machine language routine that shifts every block on the low-res screen one to the left. Okay, and then there's a subroutine for each letter. Okay, so I bet a lot of you could just hack through this and figure it out yourself and modify it to put your own messages in. I'll give more details around the 4th of July. Okay, have fun and enjoy Kansas Fest.